Hello, welcome to my channel Physics for Students. My name is Shaunak and I make videos on physics and mathematics. Well, today I would like to talk something on General Theory of Relativity. This is a subject which has been long baffling scientists, young mind aspirants who really wants to learn General Theory of Relativity. What I would do today is that I would like to speak on a step-by-step approach in which you can learn General Theory of Relativity. It has been a subject which has been puzzling or creating a lot of confusions, motivations also in terms of learning. So in this particular video, I would be briefing you about the steps to learn General Theory of Relativity. I'm also going to suggest the name of certain books. Well, these books are not just picking up the names from Amazon or Flipkart and letting you know the names. These are the books which I myself have read and I have understood the fact, and that is why I want to make you understand about the name of the books and how you can go to. First of all, what I would like to tell you is that when you are learning General Theory of Relativity, point number one is that there is nothing called a layman's approach. Okay, there are certain books, videos, internet stuffs which really claim that you can learn General Theory of Relativity in a layman's approach without any mathematics. But to be very honest with you, my dear friends, there is nothing which is called a layman's approach. You need to learn a lot about General Theory of Relativity. Before that, there are certain prerequisites in mathematics which is an absolute necessary, and you need to go through that. Back to my young days when I started, I would say got a keen interest on general theory. It was during when I was reading in class around 7 and 8, and I took one of my father's book called The Dancing Woolly Masters. Okay, this is a book by Gary Zukav. It is basically again a layman's book, but that actually initiated the interest in me to learn general theory. As you understand, these books which doesn't have any mathematical equations, they are good. I mean to say, they generate a kind of an interest in general theory, special theory, or any subject related to physics, particle physics, quantum mechanics, but they are not sufficient enough to give you a complete understanding. So my request to the young students, young aspirants is that please don't go with the the false notion that there is a general approach to any concept of physics or mathematics. No, this is just a basic idea in order to make you know about what the concept is all about. But without the mathematics, without the equations, it is not possible to understand the basic details of any physics or mathematics concept. To start with General Theory of Relativity, there are 7 important aspects which you need to know before you go ahead. I would say 7 essential prerequisites which you need to know so that you can approach general theory in a proper manner. The first one, which I would say, is Newtonian mechanics. I will explain you one by one. The first one is called Newtonian mechanics. The second one is called electromagnetism. The one Newtonian mechanics. Second is electromagnetism. Third, I would say, would be linear algebra. Fourth, I would say, is vector and calculus, including partial differential equations. Fifth would be special theory of relativity. Sixth would be differential geometry and tensor analysis. And seventh would be topology. So these are the 7 aspects: Newtonian mechanics, electromagnetism, linear algebra, then comes vector and partial differential calculus, special theory of relativity, tensor and differential geometry, and 7th would be topology. So first we would start with the classical mechanics part. Now, classical mechanics is something which we generally ignore. Okay, we are going into advanced mathematics, so what to do with classical mechanics? But the thing is that classical mechanics is the most important thing. Without a proper concept of classical mechanics, it is not possible to understand either special or general theory. Now, when I talk of classical mechanics, why classical mechanics is important? Because you will see in General Theory of Relativity, what is happening is that there are a lot of concepts which are getting, I would say, generalized. Okay, the Euclidean concept is getting into a non-Euclidean concept. I would say the space-time, which is in general gets related to space, unifies to space-time. We also got F equals to ma, which gets generalized to geodesics, right? And the general Newtonian formula, which is the gravitational formula, gets into Einstein's field equations, which speaks of the space-time curvature. So all these concepts are basically getting generalized into general theory of relativity. So number one would be to get a good hold of Newtonian and classical mechanics, because once these concepts gets generalized, if you're not getting the basic concept into your brain, if you're not clear about that, it is impossible to learn the further advanced concepts. Regarding the books, what I would like to tell you is that one, this book, Feynman Lectures on Physics Volume 2 and 3, or even you can start with Volume 1. Feynman Lectures on Physics Volume 2 and 3 would be very, very important. These concepts are very important in your further understanding. And not only that, Feynman Lectures on Physics will give you a basic, complete understanding of physics. So point number one would, the first book which I would suggest would be Feynman Lectures on Physics. Which I would like to suggest too would be Leonard Suskind's Lectures on Classical Mechanics. I'm not letting you know more about Newtonian mechanics books, because these are the certain things which you have already learned in your school days or your graduate physics classes. But Leonard Suskind's YouTube lectures on classical mechanics and Feynman Lectures on Physics Volume 2 and 3 especially, you can start with Volume 1. It would be very, very important. So I have mentioned these two books and I would recommend you to go through these books. Second part would be electromagnetism. Now you might ask me, why electromagnetism? The reason why you need to learn electromagnetism, and most importantly the Maxwell's equations of electromagnetism, because special theory of relativity actually got its approach, or it started, I mean to say, Einstein first formulated on Maxwell's equations. So if I take into account these books which I'm just mentioning you on the screen, first one would be Daniel Fleisch, Student's Guide to Maxwell's Equations, right? This is an absolutely great book. I have read it many times and I would really recommend Daniel Fleisch, Student's Guide to Maxwell's Equation. This is a book which gives you a pretty clear approach. The mathematical equations are all in detail, very clear, and you can just learn it with a basic knowledge of mathematics and physics. Number two would be Professor Thomas A. Garrity's book on electricity and magnetism for mathematicians. This is another great book. I repeat, Thomas A. Garrity, Electricity and Magnetism for Mathematicians. This would be a great book in order to understand electromagnetism. Now you might ask me a question that why electromagnetism? Now you see, the stress tensor of Newtonian mechanics gets generalized into a stress energy momentum tensor. The electromagnetic field, the electric potential, the electromagnetic stress energy tensor, all this, when it falls into the arena of general theory of relativity, it changes a lot. The electromagnetic potential, once it comes into general theory of relativity, it takes a different kind of a form. So electromagnetism is the most important thing. I would recommend these two books which I have already shown in the screen. These two books, Professor Garrity's book and Daniel Fleisch books, is a great book to learn about Maxwell's equations. The electromagnetic potential, the stress energy, I would say the electric field, all of these are getting transferred into a different way when you are dealing with general theory of relativity. So point number two, I have explained you why electromagnetism is important, and these are the books that you need to go through in order to understand. Third part, what I would like to speak is about linear algebra. Now you might be wondering why linear algebra is important. It is very, very important. Why? Let me tell you. When we will be dealing with general theory of relativity, if you have seen my video on metric tensor or on Einstein's field equations, mostly the metric tensor itself is written in a matrix form. Okay. The metric tensor is written in a matrix form. The Minkowski space is written in matrix form. The basis of vectors, once they change, the vectors, etc., all are written in a matrix form. The spherical coordinates, they are expressed in a matrix form. The spherical polar coordinates are expressed in a matrix forms. Tensors, oh my goodness, because without linear algebra you cannot get into tensors. Tensor is equally important. It gets written into matrix form. The mapping of the vector space, which is although a part of abstract algebra, gets mapped into linear form. So linear algebra is the most important thing. Learn in linear algebra, especially the matrix part, multiplication, Hermitian matrix. Entire things need to have a complete good grasp, right? Because there's the Euclidean components, the metric space, the vector space, the change of basis, everything will be written in a matrix form. The calculations will be in matrix form. So without linear algebra, we cannot think of going over. Coming to the books, here is one book. Gilbert Strang, one of the greatest authors in linear algebra. Go through this book of Gilbert Strang. It is one of the best books to learn in linear algebra. The second book which I would like to tell you is this. David Seeley's Linear Algebra and Application, right? David Seeley is one of the greatest writer, and if you can start right at the beginning, building the base of linear algebra. So David Seeley's book on linear algebra and application is a great book. Third book which I would like to show is this. Kenneth Hoffman. He has written a great book in linear algebra, and you can just go through that. Kenneth Hoffman. Fourth book would be this, Sir Glang's Introduction to Linear Algebra, and I can tell you that you really don't need to know much of mathematics to go through Sir Glang's book, this one which I'm showing you right in the screen. It is an absolute great book. You can learn it yourself, building the bases one by one, you can go through it. So this is the importance of linear algebra, Lorentz transformation, basis of vectors, metric tensor, Euclidean components, spherical coordinates, spherical spore coordinates, mapping of vector spaces through a form of linear algebra. All these are necessary. So these are the books, and this is the reason that you should learn linear algebra. Coming to the fourth part is calculus and vectors. Well, when I speak of calculus, mind it, I am specifically emphasizing on the fact of partial differential equations. You have to go through enough amount of examples of partial differential equations, which we call PDEs. Ordinary differential equation, we know it's quite easy, we have learned through that. But partial differential equation is important. Why? Because in Einstein's general, even in special theory of relativity, there are more than one factors which are varying, right? As you know, PD is deal with multivariable calculus, that is what we call it. So more the number of variations in terms of space and time and x, y, z and t, we need partial differential equations. We need to go through the book of PDE. First book which I would generally recommend, part number 1, would be this, Piskunov. Piskunov's book on partial differential equations and the entire calculus is extremely important. It is easy to understand and you can go through it. Point number 2 would be this book, Peter J. Olver's Introduction to Partial Differential Equation. As you can see, I have written it on the screen, that Introduction to Partial Differential Equation, Peter J. Olver. This is a very important book to go through partial differential equations. Okay, coming to the next part would be this book, that is Dover books on partial differential equations. I know it is a little bit expensive to purchase, but if you can manage, that would be great, because Dover books gives you a total, I would say, a basic insight into partial differential equations. These are great books which you can go through. Also, what I would do is that I would recommend this. This is basically the MIT open courseware, right? You can just go through Google and you can search. More or less these are available in PDF formats. So MIT open courseware on partial differential equation also gives you a very good insight. So my first would be Piskunov, the second would be Peter J. Olver, the third would be Dover books, and coming to MIT open courseware. Partial differential equation you cannot skip if you want to get a thorough understanding of general theory of relativity. So partial differential equation is an important factor. Next would be, although I have made the fourth point this and this, the fourth point would be vectors. Again, I would suggest you this book, A Student's Guide to Vectors and Tensors by Dan Fleisch. It is an extremely easy to understand book. Lot of equations I myself have used in my videos. So go through this book, have a clear understanding about tensor calculus, because these are important. Without without vectors you cannot move through it. Vectors, addition, multiplication, the basics of vectors, whatever is there in the book. You can go through other books of vectors also, no problem, but in order to have a understanding of GR, you need to go through vectors. Go through the minute details of vectors. Don't skip any topic which you think that, okay, this is fine, you need to go. Again, my recommendation, Dan Fleisch, Student's Guide to Vectors. This would be an extremely important book to go. Would be Special Theory of Relativity. Now, when I speak of Special Theory of Relativity, what I'm trying to tell you is that you don't have to, this is the fifth one, right? So you don't have to go through the details of special theory through rigorous mathematical forms. You need to have an understanding of the special theory of relativity. There are numerous books of special theory of relativity. First book, first let me tell you what are the things that you need to understand in special theory. Number one would be this postulates of special theory of relativity. You need to go through the postulates in a very clear manner. Second would be the concept of space-time. The concept of space-time becomes extremely important. The postulates and then the concept of space-time. In special theory of relativity, what has happened is that a lot of concepts have changed. Okay, relativistic mass is the new concept. From rest mass, you go into relativistic mass. From general momentum, Newtonian momentum, you go to relativistic momentum. Then the mass energy equivalence, the space-time gets entwined into the space and time, which was different, gets entwined into space-time. So the basic postulates of special theory, relativistic mass, relativistic momentum, speed of light, energy mass equivalence, these are extremely important. Get the concept clear, get the mathematics part of special theory clear. Coming to the book recommendation, my recommendation would be number one, this. Feynman Lectures on Physics, Volume 2 and 3. Although it doesn't speak much about special theory, but this is an extremely important asset in your library. Get hold of these books. It is available online also. You can email me if you really want to know about the availability of Feynman Lectures. If I can mail you the PDF part. So Feynman Lectures of Physics is an extremely important understanding on special theory. Second recommendation would be Professor Leonard Susskind's series of lectures on special theory of relativity. You can go through Professor Susskind's lectures. I don't need to tell more about Professor Susskind, I believe. So just go through that and get an understanding on special theory of relativity. It is a wonderful book. A series of lectures. It gives you a clear understanding, and just you can stick to your basics and you can learn these concepts. So this is what I need to tell you about special theory of relativity, the basic postulates. You can go through any other books. I think there is a book of Albert Einstein also on special theory of relativity, general and special theory of relativity. You can go through that. Pick up any good book on special theory. It doesn't require too much of mathematics, and I think it will be easy for you to learn. Coming to the final part, which is a lot of people generally get confused, or takes a lot of time in understanding, that is tensors and differential geometry. Well, first of all, you need to understand why tensor. It is a very huge topic. I cannot explain you right over this small video. Tensors are important. Why? Because they are invariant to changes. The entire edifice of general theory of relativity is built on tensors. Tensors are important in terms of understanding. Tensors are important in terms of coordinate transformation. Tensors are equally important when you change the basis, or when you move for a flat Euclidean space to a spherical or a curved space-time. So tensors are the key in understanding general theory of relativity. The second would be differential geometry. Why differential geometry? Because differential geometry is something on which the entire Riemannian geometry is based on. Try to imagine that from a flat space you're moving to a non-Euclidean space. From a flat space you're moving to spherical coordinates or anything. In this regard, you cannot really perform the normal Pythagorean or any normal Cartesian equations in order to measure the distance between 2 points, right? You have to do calculus. And I have shown in my video in metric tensor that you get a manifold which is a little bit curved like this surface of this hand or something, and there you can perform the differential calculus. So that is why differential geometry is important, because we are no more into Euclidean space, flat space. We have moved ourselves directly into differential curved space, which would require differential geometry to understand. Coming to the books of tensors, obviously first you can refer to my playlist on tensor analysis. I have got this in my channel in Physics for Students. These are good resources. I won't say great, but these are good resources in order to understand tensor. Second, my suggestion would be again this. Daniel Fleisch books on vectors and tensors. You can skip the vector part now and go into tensor part. It is a wonderful book. It gives you details about tensors in a very lucid manner. You can go up to Riemannian curvature tensor also in this book. Coming to the third recommendation of my book, it would be this. Tensor Calculus by J.L. Singh and H. Child. This is also a book which builds up right from the basics. Tensor Calculus, it is right on your screen. You can go through that. It is a good book. You can build up your tensor calculus easily. My next recommendation of tensor calculus would be this. Principles of Tensor Calculus by Taha Sochi. This is not a very common book, but I personally have gone through this book. It contains huge amount of illustrations, basic ideas of tensors, building up slowly with indices and contravariant and covariant. It is a wonderful book to go through. My next recommendation would be this. Schaum's Outline of Tensor Calculus. You can go through that. It is a wonderful book. It gives you a basic understanding of tensor calculus, and I think it is easy to understand. My next recommendation would be this. Manifolds, Tensors and Forms by Paul Renton. Okay, this is a very good book which gives you a thorough understanding about tensors. Now you see, when I was struggling to understanding of this book, Manifold, Tensors and Forms, actually it gave me a complete understanding on what is a differential manifold. Right, so differential manifold deals one part with topology, the second part with metrics. So the topology is something where you really understand the closeness between these 2 points. Right, topology, and then in metric you measure the distance and comes the geodesics, etc. So these are the books which I would really recommend you to go for tensors. Right. Coming to the next part, which is differential geometry. I have already explained you why we need differential geometry, because we are not into the flat space anymore and we need to differentiate the space in which we are really working. So my first recommendation of the book of differential geometry would be this. Elementary Differential Geometry. This is by Martin Rosen. It is a book which I have gone through. Wonderful book, easy to understand. So you can just go through that book and understand and start learning on your own differential geometry. My second recommendation of the book would be this. Differential Geometry of Curved Surfaces. This is by Thomas Banco. Right. This is also a wonderful book. I won't say a little bit advanced, but it assumes certain basics of tensors which I think you already know or you will be building up, and you can go through this book. My third recommendation is this book. Elementary Differential Geometry by Andrew Presley. This is a Springer book, and as you understand, the Springer books are mostly research works and they are absolutely great. Go through this book. My next recommendation for the book would be this. Curved Spaces by P.M.H. Wilson. This is also a great book to go through. You can just get hold of a basic concept of understanding of differential geometry. Really a YouTube learner and you want to go through books which are, I would say on YouTube lectures, I would recommend one person. I really respect him, Professor N.J. Wildberger's series of lectures on YouTube on differential geometry. Go through Professor N.J. Wildberger has mostly, I would say, most of his videos are on the history of mathematics, but he's a great teacher of differential geometry. Go through the series of lectures of N.J. Wildberger's differential geometry. Coming to the last part, which is topology, I won't take much time, and I won't also recommend you that you really go through the details of topology, not required. Just go through the basics of topology. So my first suggestion would be this one. James R. Mooncrest Topology. It is a classic book on topology. You need to have it, you need to understand, and it starts with the building with set theory concepts and it gets into detail. So James R. Mooncrest's book on topology is a Bible. My last recommendation for topology would be this, Topology Without Tears. This is, I think, by James Morrison. I just forgot his name. So Topology Without Tears is also a great understanding on topology books, right? So these are the 7 points which I wanted to tell you. These are the prerequisites that you need to know before you get into General Theory of Relativity. If you really want to understand the General Theory of Relativity by reading books, my first recommendation for the book part would be this: Professor Anthony Z's Einstein Gravity in Nutshell. It is a mathematical book, but it starts with the basics. Wonderful to read. You can learn on your own. So just go through this book. Professor Anthony Z's Einstein's Gravity in a Nutshell. The second book, which I still have in my shelf, even on my table, which I go on reading daily, is Gravity by James Hartley. It is there on your screen. You can understand this is a wonderful book. In fact, Hartley and Stephen Hawking developed the steady state theory. It doesn't contain too much of mathematics, but the mathematics that much which you need. My third recommendation would be this: Bernard Schutz's A First Course on General Theory of Relativity. This is again, I can say, a Bible. It is a fat book, more than 400 pages, I think. But don't worry, it gives you a thorough understanding about General Theory of Relativity. My next recommendation for a General Theory of Relativity book would be this one: Gravitation. It is written by Misner, Kip Thorne and J.A. Wheeler. All are great mathematical physicists, most of them from Princeton in Cambridge. So Misner's, although these are 3 people who have written on gravitation, it is a great book to read through. It contains a lot of further details on cosmology also, but you can look into this. The next recommendation of my General Theory of Relativity would be this one: Sean Carroll's Space-Time Geometry. This is a great book to read through. I would recommend that this is the website which I am showing you, preprosperousuniverse.com. This is a website of Sean Carroll. You can go through, you can learn. But Sean Carroll's book of Space-Time Geometry, it is a wonderful book, very easy to understand. The next recommendation of General Theory textbook would be Steven Weinberg's Gravity and Cosmology. This is, you know who is Steven Weinberg. I hope you don't need to explain. So this is another book on gravitation and cosmology, and you can just go through it. It carries all the intricate details. The last one, which would be a series of YouTube lectures by Thanu Padmanabhan. I'm sorry to tell that he recently expired. He has brought some great series of lectures on General Theory of Relativity. Go to YouTube, search Thanu Padmanabhan, and you can find out all the details of General Theory of Relativity. He has gone into a series of lectures of general theory. Last and the most important is Professor Leonard Susskind. Well, before I go and tell you about Professor Leonard Susskind's videos, one thing I would really like to make a caution is that because he is one of the greatest teacher of physics and mathematics, the problem is that whenever you get into General Theory of Relativity, looking into his lectures, he generally, discovers, or I would say gets into certain great concepts which are, a little bit out of the way. He would analyze and get into certain concept of differential geometry, gravity as a whole, that it might not sound something which is strictly into General Theory of Relativity. So I would like to make a note to all the viewers over here that when you are listening to Professor Susskind's lectures, especially on General Theory of Relativity, try to make an understanding that he always have a great understanding of the concepts and he evolves into certain concepts. I cannot tell you right now because this is not the video to talk about. He evolves into certain concepts which are not into GR directly. So you might find that he is getting off track. No, he is a great mathematician, great teacher and a great scientist. I consider him to be my greatest guru. But the problem is that these gurus, they have so much of understanding that they try to get into certain things which are always not relevant to the student. So just take a note while understanding Professor Susskind's videos. Well, this is almost half an hour I have been talking about general theory of relativity. What I would like to make a note before I end this video is that just go on reading and reading even if you don't understand. Just go on watching and watching the videos even if you don't understand. Because general theory of relativity for Einstein and great mathematician, it took 12 long years to design. 12 long years for these great fellow mathematicians, great Nobel laureates to the entire video. Do you think that you can make it in just a quick time, just in an easy way? So no. So just go on reading the topics, just go on listening to those topics. With maturity, with time, the concepts of GR will eventually get into your mind. With the passage of time, once you learn more of mathematics, once you just close down your eyes and try to visualize the curvature, the acceleration, the equivalence principle, the tensors, the Christoffel symbols, everything, they will generally get into your mind. Don't worry about this. It will slowly build with time. You see, I am constantly looking down here because I have made certain points so that I can be very clear to make you understand about all those things. So just take your time. All my best wishes are there. It will take time for you to develop the concepts. Read on, don't stop. If you don't understand, skip. If you are unable to understand what you are hearing in your ears, skip. Go on reading and reading. I can tell you this really helps. For me, for others, there are certain concepts which you are not going to understand. There are certain concepts which is just out of your head. It goes just like this. But don't worry. It will come up. It will take time. All those books which I have just mentioned here, these books I have read. I have not picked up from Amazon and just giving you the names. I have read, I have understood, and it is really wonderful to go through these books. 7 important points. Again, I repeat, Newtonian mechanics, very, very important. Electromagnetism, extremely important, both for special theory and for general theory. Calculus and especially partial differential equations and partial differential equation and vector, that is also very important. Linear algebra, without that which you cannot move. Linear algebra is very important because all the metrics and all the special relativity, Minkowski space, everything is on linear algebra. Point number 5, the basic postulates of special theory of relativity. A lot of books are there. Pick up anything and understand special theory. Point number 6 again would be topology, a basic understanding of topology, and tensors and differential geometry. I have not made enough amount of, I would say just one video on differential geometry, but I am trying to make more, and I have got a good amount in tensors. Go through my playlist in tensor, you will be able to understand. Right, so this is a video which I have been willing really long to make it because this is a topic which really demands a lot amount of study, lot amount of concentration and good books. So that's all. I am signing off from today. Please do subscribe, like and put up your comments in my channel. You already know about my website. This is here, physicsforstudents.com, which you can visit, you can contribute, and please do click on the bell icon so that you get all the notification from Physics for Students. Thank you very much for watching this video. Keep well, stay happy and keep on learning. Bye.